So, dear students, let's start with the interface design. Uh, for performing interface designs, a user interface design creates an effective communication medium between human and a computer. So, whenever you think of you want to, as we have already explained in our last and frequently in the class as well, that at the two ends between a user and a computer, okay, there should be an interface that can help us to make sure that the user understands the whatever it is the thing is implemented here, and whenever the user responds back, the interface is such that the computer understands what the user is asking for or what the user is like, what the user want to see on the console. Following a set of interface design principles, design identifies interface objects and actions and then creates a screen layout that form the basis of the user interface prototype. Okay. So there are certain set of principles that guide us in this effective communication between a human and a computer. So what are these basic principles or rules? You will see here now. These rules are called as golden rules of interface designs, and it has three rules. One is, the first rule is called a place the user under control. Second is the reduce the user's memory load, and the third is to make interface consistent. The thing is, if you are under control, if you are having, if the design governs you, right? It means the place the user under control means the user is is of this perspective that he is governing the design. Okay, what he want to see, he's able to see on the screen. This is what it actually means. So the tagline, which you must have heard many times, uh, that if you want to sell something, you need to have, you need to like, you need to have some good quality, right? So the user is under control, the user will come back again and again to the interface itself, and will be learning or will be using this interface over and over again, right? Second thing is, the interface will be such that it should reduce the memory load of the user. The cognitive power of human being is such that he doesn't want to spend more time thinking and analyzing and something like this. Okay, he wants that transfer that particular cognitive process to the computer, and the interface is the first thing that he interacts with, and through which he wants to transfer this memory load, share this memory load. The third is, the interface should be consistent. That means it, if it is of the same color, if some you are displaying something with a particular color on a screen, in the next screen the same concept should follow with the same color coding. Okay, if you are having one word for representing a label here, and the second screen you should use the same word, same wordings or same structure to represent the same label. Should not changing, you should not be, so there should be a consistency between the interface objects. Let us start with the first rule. The first rule says that the place under the user under control. The design principles that allow you the user to maintain control are: the first thing is, design interaction modes should be chosen in a way that they does not force a user into unnecessary or undesired actions. Okay, suppose you are using a mobile phone and you're typing a particular message using your keypad, and you are having an spell checker. You know that you have one predictive word or a spell checker option. Now this predictive word or spell checker is designed to assist you. Okay, now if that particular module is always taking lead and always assisting you without any you don't want assistance, you want to write something in English, suppose, but the word matching to the in direct dictionary turns up every time and changes your content. Okay, then you will feel irritated, right? You don't want to use such keypad, you change that keypad. Okay, So that's what the interaction mode should be chosen in a way that it should not force user unnecessary and undesired action. So if you it's unnecessary action, I don't want your help. You're giving me help. I don't want it right now. So that's what the first thing is. When you design, the design should always assist, but the assistance should be on the choice of the user. Second is it should provide ways for flexible interactions. Like suppose I don't have my keypad stop working. So what I can do, I can use touch, and I can record a voice and I can input a voice. Or suppose I have a digitized pen, so I can give my interaction. I can give my commands using the pen itself or the movements of my mouse itself. So you should have multiple options for inputting a particular value. Now you can see that you have a virtual keyboard mostly in the online banking systems. Uh, it is one of the thing which helps the user and place the user under control only. But what are the use? Because suppose my keyboard stopped working, my mouse is working. So if I have that on virtual keyboard option available, what I can do, I can just use that virtual keyboard to enter the username and password and whatever things is required for logging into the internet portal. This is what I can do. So this is much better option for that if the interface gives me. Second thing is, might it possible that your system has been affected by a virus, and the virus reads all the keystrokes that you do in your computer, right? So what the physical keyboard. Now, if you have a virtual keyboard, the virtual keyboard is not a physical part. So if you use that keyboard, the strokes will not be recorded by any of the bot, right? Suppose. So that's one of this another way of looking why we have a virtual keyboard. The third thing is it allows user interaction to be interruptible and undoable. So uh, if a user does one of the action, he is having a choice to stop the current process, right? If it's deleting certain thing, the system asks him whether you want to delete it or you don't want to delete it. Okay. When he takes an option that yes, I want to delete, he is giving his consent. So now the thing will be deleted, right? But again, now what happens when you delete an object from your device? It doesn't delete it permanently, right? It goes to a temporary storage, rest it for certain amount of time, and then it deletes from that particular location after that desired time threshold is over. So if I give you example, you have Google Photos where you have open your my Android mobiles. You have when you use the Google Photos, you delete one of the photo from the Google Drive, and it doesn't delete right now from your Google Photos, right? It goes to a bin option. It resides in a bin for 30 days, and in within these 30 days, if you remember that, oh, I need this, I mistakenly deleted one of my important photos, I want to recover back. So what I can do, I can just go to the bin option. I can restore that photo or the video back to my uh, original location. Okay. So the interaction is undoable. That means I can redo that particular thing. The last is designed for direct interaction with objects that appears on the screen. Okay. Design for direct interaction means suppose this thing is very useful when I want to interact with the objects that are appearing on the screen, like a video. If a video is running and I want to pause it, I can pause it, right? Now, if it's a photo, I want to enlarge the photo with my fingers, with my fingertips. I can do this. If I put two fingers and expand them widely, the photo enlarge. If I want to bring back that photo back to its original size, I can again bring these two fingers together and close that gap. So it will again comes to a normal size. What you're doing, you are in that interaction with the object that appears on the screen. Not all the objects you can interact, but some of the objects which actually requires the interaction should be interactive enough. So when you have all these four things, the user feels that yes, he is actually governing the interface. So what you see is interface is just not the GUI which you think of, right? Interface is anything from which with the help of which you are interacting with the computer or the system. The next is to reduce the memory load of the user. The more user has to remember, the more error prone interaction will the system be. Okay. uh, the thing is, humans generally suffer from a memory loss type of issue, that he doesn't want, because the memory is continuously involved in multiple other activities day in and day out, right? So what the user interface should do is, he should remember some quite vital information which is required to interact with the interface, and which is burdening this particular user. Okay, so I should take down the burden from the user regarding that particular aspect, so that the user does have to tax for learning or remembering that type of information. Because if I want to remember, if I have 10 login screens and I have to remember 10 different passwords for each of the passwords, my memory will be so taxed, and I will surely make some mistake, right? Because I couldn't remember all the 10 password, other than I can write it down somewhere, change it every time I need it. So that's why we have something called SSO. Okay. With the help of this SSO option, if you have heard this option somewhere, what you will do is, this is single sign on, right? That means with this particular login option, you have to log in once, and all the application behind it will run with the single login. Okay. So its example is, you can log in into Google account once. If you want to access Drive, if you want to YouTube, if you want to Doc, if you want to read news, you can do any of the options with this single login. Okay, so this is known as SSO. It is for this reason that a well-designed user interface does not tax the user memory. We have talked about this. Whenever possible, the system should remember pertinent information and assist user with the interaction scenario that assists recall. That's why you are having one checkbox. Whenever you see a login, it says remember me, right? When you tick this, it will remember your user information. Next time you come back, it will just load it with that particular username and password. Okay. So this is why we use we want to reduce, because we want to assist first of all the user, and we want to make it more interactive, and we reduces the taxing of the user memory. The third thing, now the following the means can be used to reduce this memory load of the user. First thing is to define shortcuts for that are intuitive. Suppose I want to print a particular page, and I want to remember how that I should go to file, click this file, go to print, and then the system will print me. So I can, if I want to use it faster, then I will use keyboard. So you have seen people using keyboards in banks and many other areas, because using a mouse takes more time, using keyboard takes less time. So they have designed these hotkeys. Hotkeys are these keys which represent a system function, like Alt plus P is for printing a particular file. Okay, and the mnemonics should be tied to the action in a way that is easy to remember. So P stands for printing, like select all. Control A is for selecting all. Control S is for saving. Control C is for copy. Control V is for paste. Now I cannot use P again for paste, because I have already designed it for printing. Okay. So but wherever possible, you should be tying this mnemonics, this key, the word, that the alphabet that you're using, with the key, and you're creating your own uh, mnemonic for the shortcuts for reducing the load. The visual layout of the interface should be based on the real world metaphor. Example: a bill payment system should use a checkbook or a check register metaphor. So it's same as if you go to an online reservation site and you want to enter uh, the details. So it gives you from date to date, and then you are having like a list of passengers, right? The labels that you see is actually the same as you will do it in physical uh, forms. Okay, so the user can actually correlate these things easily. Okay, he will learn the particular interface very easily, and that will reduce his load for understanding that particular interface. The third is it disclose information in a progressive manner. Small steps, in a small increment, it disclose more details to a user. The interface should be organized hierarchically. That is, information about a task, then object or behavior should be presented first at a high level of abstraction. More details should be provided after the user indicates interest using a mouse pick. Okay, or whatever the thing. If you want to learn more, some more information is there, right? But if you don't want to learn, you have sufficient information to navigate to learn to navigate this interface. It's easier for him. So you should disclose the information in a very progressive manner. Okay, these are the three basic ways in which you do. The third thing is make the interface consistent. The interface should present and acquire information in a consistent fashion. That this means all visual information, example window, title, graphical icon, color, coding, etc., in the is organized according to a design standard that is maintained throughout the screen display. Okay, that means everything should be consistent. If you're using one window title in a particular page, and then you never different the same subsection of the page, the window should say about this is the screen related to your original screen. Okay, suppose you are having one screen here, and you are having a window title say X. Okay, and then you navigate it to a next screen which is the child of this X. Within this you click one link, the link takes you to this screen, and the link was supposed to say Y. This thing should actually say X then Y. So what will happen, the user will know that you are on the X, and within the X you are reading Y. Okay, when you come back again, go to X. Okay. Okay, so this is how it actually happens. And the second thing is input mechanisms are constrained to limited set that is used consistently throughout the application. So the user is not confused when to use what type of information. So how should I input the information? If I change every time, sometime I take input from mouse, sometime I take input from keyboard, sometime I take input from like voice, the user will confuse how many type of inputs are there. So that if you want to take input, then consistently from the two in types like audio and keyboard, so it will be consistent. Every screen should talk about this only. So this should be consistency of taking how to take input. So we constrained to a limited set of input types. The third thing is mechanism for navigating from task to task are consistently defined and implemented. How to navigate? Okay, sometimes you don't allow back button to come back to the previous screen. Okay, it's really true because I don't want the browser back button to come back to a previous screen. I want my own back button to actually work. Okay, so the thing is, sometimes when you click a back, it will take you a different page when what actually with the back button which you have designed in your screen will take to. Okay, so the thing is this. So you should have a proper mechanism for navigating from task to task that are also consistent and defined and implemented. So once you know all these rules, with the help of these rules, actually design and analyze the models or interface. So we will see that interface analysis and design models here. Basically, there are four models. One is called the user model, one is called design model, one is called mental model, system perception, and one is called implementation model. Okay. So in our next lecture, we will be reading about the interface design and analysis model and completing this particular uh, topic. You can also go and read the sections actually being given to you over the classrooms.